Now, sometimes you're going to get things like number 8 and 9. You're going to get these rational expressions where the degree of the numerator is greater than or equal to the degree of the denominator. If we take a look before we keep reading, the degree of this numerator, so the power that x is raised to is 1, and the degree of this denominator is 1, so 1 is equal to 1, so here the degree of the numerator is equal to the degree of the denominator. Here the degree of the numerator is 2, the degree of the denominator is 1. Well, 2 is bigger than 1, so for number 9, the degree of the numerator is bigger or greater than the degree of the denominator. Now, if that happens, what we have to do is first perform long division of polynomials, and then we have an integrand we can integrate. We are going to be performing long division of polynomials for number 8 and 9 to end up with something that we can integrate. Number 8 is the indefinite integral of 3x over x plus 4. I notice that it's a rational expression where the degree of the numerator is equal to the degree of the denominator, so I start with long division of polynomials. My divisor is x plus 4, it goes on the outside of my division bar. And my dividend is 3x, and since that is a linear term, I have to go all the way down to constant. I don't have a constant term, so I add in a plus 0. Now when I'm dividing, what I need to do is figure out what do I need to multiply this x by so it becomes that 3x. Well, a 3. Now I multiply 3 times x is 3x. 3 times 4 is 12. When I do long division, I now subtract. So I'm subtracting 3x plus 12, so make sure you distribute that negative to both of those terms. 3x minus 3x will cancel. If they didn't cancel, you've done something wrong. And then 0 minus 12 is negative 12. What does that mean? That means that this becomes the indefinite integral of your quotient, which is 3, plus your remainder, negative 12, over your divisor, x plus 4. Now we're something that we can integrate. Well, the first thing we know is that we can split this up into two separate integrals. So we're going to look at this as the indefinite integral of 3 dx, and then plus a negative is really minus. This 12 is a constant multiplier. We're going to pull it out of the integral, and all we're left with over here is 1 over x plus 4. Well, this here is basic form. I know how to integrate that. My other one I can use a u sub for. If u is equal to that denominator x plus 4, and I forgot my dx here. The derivative du is dx, which is perfect. That's exactly what I have. I'm going to bring this guy down. And then this becomes the indefinite integral of 1 over u du. We integrate and we end up with 3x minus 12 times the natural log of the absolute value of u plus c. Get out of u's and go back into x's. And our final answer is 3x minus 12 natural log of the absolute value of x plus 4 plus c. Number 9, the indefinite integral of 4x squared minus 7 over 2x plus 3. Well, it's a rational expression, and I notice that the degree of the numerator is bigger or greater than the degree of the denominator, so I start with long division of polynomials. I grab the divisor, 2x plus 3, and that goes into my dividend of 4x squared minus 7. Well, notice I don't have a linear term, so I add in a 0 placeholder for my linear term, and then minus 7. Now, what do I need to multiply 2x by so it becomes 4x squared? Well, I need to multiply it by 2x. So I line this up. 2x times 2x is your 4x squared. 2x times 3 is 6x. Now I subtract, but remember I really need to change these signs, so it becomes a negative 4x squared and a negative 6x. 4x squared minus 4x squared will cancel, and then 0x's minus 6x's is negative 6x. Bring down your next term of negative 7. Now ask yourself, what do you need to multiply 2x by so it becomes a negative 6x? Well, negative 3. Negative 3 times 2x, negative 6x. Negative 3 times a positive 3 is a negative 9. Remember, you're subtracting now, which really means you're changing your signs, so both of those become plus signs. Negative 6x minus 6x will cancel. Negative 7 plus 9 is a 2. Therefore, we know that we're really looking at the indefinite integral of our quotient 2x minus 3 plus remainder over divisor. Well, we can split this up, the indefinite integral of 2x minus 3 dx plus the indefinite integral of 2 over 2x plus 3 dx. If we use a u sub for this portion right here, because this is just basic form, if u is equal to that denominator, 2x plus 3, the derivative du would equal 2 dx, which is perfect. That's what I have. I'm going to bring this guy down, the indefinite integral of 2x minus 3 dx plus, and over here this became the indefinite integral of 1 over u du. Integrating, we end up with, this would be 2x squared over 2, or just x squared, and then minus 3x, and then plus the natural log of the absolute value of u plus c. Getting out of u's and back into x's, we end up with x squared minus 3x plus the natural log of the absolute value of 2x plus 3 plus c. Now I just want to make sure that we're all really careful. You're never allowed to split your fractions up over the denominator. So please never do this and try to say 4x squared minus 7 over 2x plus 3 is equal to this first term over that first term and that second term over that second term. You cannot do that. You cannot separate the denominator of a rational expression. The last three examples in this section deal with finding the definite integral. Now remember, the definite integral has your lower and upper limits of integration, and it just gives us the net area under the curve. And the difference between the indefinite integral and the definite integral, other than the fact that it gives us the net area, is that we're not going to need our plus c when we integrate, because the indefinite integral was that family of functions, so we needed the constant of integration, but we won't need that for our definite integral. So let's do the next three examples. Now the homework is asking you to use a graphing utility to verify your results, but we're not going to do that in the video, and I wouldn't ask you to do that either on your exams. Evaluate the definite integral. I look at number 10. I have the integral from negative 1 to 0 of x times the square root of 1 minus x squared dx. Well, that's not basic form, so it makes me think that this needs a u sub. Well, I'm going to rewrite the radical as a rational exponent. So we're looking at the indefinite integral from negative 1 to 0 of x times 1 minus x squared raised to the 1/2 dx. Well, if u is equal to what's being raised to the power, 1 minus x squared, the derivative du would equal negative 2x dx. Well, I don't have a negative 2x dx. I have a positive x dx, so I divide by negative 2. Therefore, negative 1/2 du is equal to x dx. Well, this then becomes the definite integral from x equal negative 1 to x equals 0, because I'm not changing my limits of integration to limits of integration in u. And then we are looking at u raised to the 1/2 power, and then we have negative 1/2 du. Now we are basic form, so this is negative 1/2 times, if I integrate u to the 1/2, that's u, raise it to 1 more, 3/2, and then times the reciprocal, 2/3, and this gets evaluated from negative 1 to 0. These 2's cancel, and we have negative 1/3. Get out of u and go back into x. 1 minus x squared raised to the 3/2 power, evaluated from negative 1 to 0. Plugging in the limits of integration, plugging in a 0, 1 minus 0 squared is just 1, raised to the 3/2, that's going to be 1. Plugging in a negative 1, 1 minus a negative 1 squared, well 1 minus 1 is 0, and 0 to the 3/2 is just 0, so in the end here, we end up with negative 1/3. Number 11, the definite integral from 0 to 3 of 6x over x squared plus 1 dx. The first thing we do here is try to figure out if we're basic form. No, we don't look like basic form. So we try a u sub. Let's let u equal the denominator. If u is equal to x squared plus 1, our derivative would be 2x dx. Well, I don't have a 2x dx, I have a 6x dx. That's not a big deal. Multiplying both sides by 3 du would equal to 6x dx. That means that we're looking at the definite integral from x equals 0 to x equals 3 of 1 over u and then times 3 du. Integrating that, we get 3 times the natural log of the absolute value of u, and this gets evaluated from x equals 0 to x equals 3. Getting out of u's and back into x's, we know u is equal to x squared plus 1. And that gets evaluated from 0 to 3. Plugging in the limits of integration, 3 squared is 9, and 9 plus 1 is 10. And then 0 squared is 0 plus 1 is 1. Well, the natural log of 1 we know is 0, so this term just becomes 0. And our final answer is 3 natural log of 10, and we don't need the absolute value bars because 10 is already positive. Alright, our very last one, the definite integral from 3 to 4 of 1 over x times the square root of x squared minus 4 dx. Well, the first thing that I realize is that this is basic form. This guy here is my inverse secant. Since it's inverse secant, I need to identify what is u, what is du, and what is a. Remember, u is always the variable, so my u squared is equal to x squared, therefore u is equal to x. Does that match what I just wrote down? Yes. And then your du is equal to dx. Perfect. Your a squared is 4, therefore your a is equal to 2. That means that this is going to equal 1 over a times the inverse secant of the absolute value of u over a, and then evaluated from 3 to 4. Plugging in the limits of integration, we have 1/2 times the inverse secant of the absolute value of 4 over 2 minus 1/2 times the inverse secant of the absolute value of 3 over 2. Well, the absolute value of 4 over 2 is just 2, and the absolute value of 3 over 2 is just 3 over 2. Well, do I know where the secant is equal to 2? Can I find the inverse secant of 2? Yes, that's equal to pi over 3, so I know that this is 1/2 times pi over 3. Do I have any idea where the secant is equal to 3/2? No, I don't know what that number is, so I'm going to leave it alone. Finally, if I multiply these together, I end up with pi over 6 minus 1/2 times the inverse secant of 3 over 2. Now, WebAssign's always going to be looking for these exact answers. So if you end up again with something that doesn't return a known angle, for example, we have no idea where the secant is equal to 3/2, you're just going to be leaving that as part of your answer. That's it for basic integration rules.